All right, into the 4.7 inverse sine function, or an inverse trig functions in general. Now, when you have a graph, let's say we're looking at the graph for sine. Y equals sine of x. So something like this, right? We can tell it's a function because it passes the vertical line test, right? The waves just keep going left and right. But everywhere I do a vertical line, it passes the test, so we know it's a function. Now, functions sometimes have what they call an inverse function. But for a function to have an inverse function, it has to pass the horizontal line test, meaning I only cross it once when I draw a horizontal line. And as you can see here, because of all the waves it has, right? It's very easy to see that if I draw a horizontal line over the graph, I'm going to cross it more than once, right? I mean, you can right away tell from the x-axis alone, right? The x-axis crosses it a bunch of times, infinite number of times. So technically, the way it is here, it doesn't have an inverse function. But what we can do is just use a piece of this. So if I use from here to here, so from a minimum to a maximum, right? That way the whole range for the graph is included, because this is as low as it's going to get anywhere in the graph. This is as high as it's going to get anywhere in the graph. So here I have a copy of all the values that the graph, all the y values, right, that this graph has. But I'm going to just keep it to this this piece. So if I define y equals sine of x just from here to here, then it does have a inverse function, because as you can see that piece in the middle, I can draw horizontal lines as much as I want, and I'll never cross it more than once. So for this reason, when we do work with inverse trig functions, you'll have a domain that you have to worry about. This will be from negative pi over 2 to positive pi over 2. So for this domain, we are allowed to have a inverse function, okay? Definition. Inverse sine function. We will define it as y equals arcsine of x. If and only if another way to say this is if with two f's, by the way, in case you run into that sometime. Sine of y is equal to x. And then we have some restrictions here because of the way we had to cut the graph. So x is between -1 and 1. And y is between negative pi over 2 and pi over 2. Okay, so the domain, when we were working with sine, the domain was all real numbers, and the range was -1 to 1. For arcsine, it's a little different, right? The domain is now from -1 to 1. These are the x's that we are allowed to plug into this function. And then our range, right, what we get out of it, will only be from here to here, because we're only using that piece, right? Example 1. Find the exact value of each of these expressions. Part A. Let's do arcsine of -1/2. So think of this as y equals arcsine of -1/2. You can see another way to think about this is, sine of y is equal to x. So I can also write this as sine of y is equal to x. So sine of something gives me -1/2, right? So I want that something, right? I want that angle. Now for sine, if we use a unit circle, what is sine? Is it x or y? See if I picked the right one. I always pick the one that doesn't open correctly. That'll do. Well, sine is y, right? So we want a y that gives me what value? -1/2. So let's start looking. -1/2 for the y, right? There's one here, and here. So this one is sine of 7π/6. This one is sine of 11π/6. Which one is it? Which one is the answer? Sine, we know that sine of 7π/6 is this, and sine of 11π/6. What do you think? Which one is the answer, if I can only have one answer? So what are we looking for here in terms of the y and x of the function? We're looking for y. Y is between here. That makes sense? In terms of the circle, right? Where is that interval? So -π/2 to π/2, right? So if this is 0, π/2 is where? Here. So 90 degrees, right? 90 degrees up. And what about -π/2? I would go down this way. So the angle has to be in this right side of the circle. Does that make sense, everybody? So that means 7π/6 is out. Right? Must be. And let me actually rewrite it this way. So how would I write that in terms of a negative angle? Because the other issue is that 11π/6 is larger than the two values they gave us, right? It's larger than π/2. So I have to put it in negative terms. So how do I change that to a negative angle? Okay, let's see. Let me cross this out first. Of the function. This is right side. Of the circle. All right, go back here real quick. We need to change 11 pi over 6 to fit the interval they gave us, right? 11 pi over 6 is 330 degrees. So in negative degrees, this would be negative 30, good. 30 is represented by pi over 6, so this will just be negative pi over 6. Negative pi over 6. All right, negative pi over 6. Okay, any questions on that? And that is really the trickiest part about these, okay? That's the trickiest part of it, really. B, once you start getting the hang of it. Inverse sine of square root of 3 over 2. So inverse sine means the same thing as arc sine. So think of this as arc sine of square root of 3 over 2. Sometimes this can be confusing in terms of the knowing if they're giving you the x or the y. So that's why it's a little tricky, right? So sometimes people might say, oh, when I see arc sine, I know it's y equals arc sine of x, right? But then they see inverse sine, and because it's different than arc sine, they might think this is the y instead of the x, right? So it confuses things. And you do need to know what you're working for, right? If you're looking for y or x, because remember they have different restrictions, right? X can be between here and here, and y has to be between here and here. All right, so square root of 3 over 2. So we know that sine of y will give us that. Sine, of course, is the y coordinate, right? We need square root of 3 over 2, but we already know that we have to stay in the right side. Right? So what angle is it? Pi over 3, yeah, that's good. So square root of 3 over 2 and the y value is at 60 degrees. That's pi over 3. And pi over 3 is within that interval that we need. Good. Be careful there, of course, because sometimes people will choose the x value by mistake. But remember, that's for cosine. We're looking at the y values for in the unit circle for sine. Okay. C. C is inverse sine of 2. So this would be the same as looking for a y, for which when you take the sine, we get 2. Which one would it be? what do you notice about the unit circle? Yeah, what is the highest? All right, let me put it this way. When I look at the side graph, right, we said it looks like this. What is the maximum and minimum? 1 and -1, right? So I need the sine of something that will give me 2, right? Sine of some value has to give me 2. But if you notice, sine of anything here, at the most, I'm going to get 1. Does that make sense? So it doesn't work for this. Right? Not possible. So let's write. Oh, they just wrote not possible, so that works. There's no angle whose sine is 2. I guess if we wanted to be more exact, we could talk about the domain, right? X cannot be bigger than -1. Cannot be lower than -1 or bigger than 1. And 2 is definitely bigger than 1. Okay, so we'll stop there. I'll pick up with example 2 in the next class, okay?